Thanks to everyone who's joined us today. On behalf of the Passive House Institute New Zealand, this is welcome to our next sort of session of the 2025 webinar series. This session is the builders version of the session on alternative wall systems for passive house projects and other projects too. So last session we had taken a designer's focus. This time we'll be focused more on the construction side. Just a little bit of housekeeping. We'll be recording the session, so if you can turn off your camera and your microphone. If you can post questions in the chat, and we'll pick up those in the end. And if you see any questions in the chat that you like, then if you can give those a thumbs up, and if we don't have time to answer all the questions in the chat, we can focus on those ones that seem to be popular. So thanks again to our sponsors, Atomai, NZSIP and StrawSIP. Participation and contribution of these sponsors is enabling us to run this webinar series. And thank you also for making a difference in the direction of our construction industry and what is a challenging time for everyone. Just a quick overview. What we're going to cover. So this is broadly similar to the layout of the designers webinar, but as I say, with a slightly different focus. So some of this material will be familiar if you've been to that webinar, but we'll move through the technical section a bit quicker. So a quick intro, then a little bit of background on the Passive House standard. Then moving on to what in particular are the requirements for wall systems for passive house and other projects where you're targeting significant improvements over the building code. And what are the problems that we have at the moment with business as usual, and what are the solutions, and then we'll move into a interview section of the webinar, and then we'll finish off with any addressing the questions that have come through in the chat. So Glenn will be looking after the interview section, which will be most of the webinar, and I'll, as I say, just be sitting in the background during that point, and I'll just do the technical section, covering off this background that I've just gone over in the overview slide. So Glenn and myself, I'm an architect, Glenn's a builder, both with Passive House qualifications, both involved with the Passive House Institute. So I'll just try and lean heavily on Glenn's extensive experience, and I'll, as I say, try and keep to the background. And thanks again to speakers coming from our sponsor companies. So Michael from Atomai, James from NZSIP, and Stefan from StrawSIP. And we'll do a little bit more introduction after we get into the technical section and when we're getting into the interviews. But thanks again. Just a little bit of background on Passive House Institute. So Passive House Institute New Zealand was formed 2012 and has from the outset been focused on closing the gap between how we'd like buildings to perform and how most of them are performing at the moment. And we do this via advocacy and supporting research, and also through education, as we are here today with this webinar. If you'd like to find more out about PHINZ, you can check out our website, and we're on social media as well. We are a member and sponsor supported non-profit. So as I say, if you could consider supporting us through a membership, if you're not already a member, our member directory is actually one of the most visited pages on the website for people looking for passive house professionals. So we are also offering sponsorship, so for the organisation as well as events. So please reach out to us by email if this is something you're interested in, and we would love to have your support. And also, if you can check out our events page for future webinars. We also have local events. We have local chapters in most part of the country. So Glenn is the local chapter lead for Nelson and Marlborough. So I encourage you to regularly check out the events page, and we're also posting events on social media as well. So thank you. And just a disclaimer, so we do provide and support education. We're committed to building knowledge and understanding within the construction industry. And while this webinar and others are offering introductory insights into, in particular here, alternative wall systems, it's not intended as a substitute for a detailed project consultation. And we, of course, strongly recommend that anyone who's interested in using these systems pursue further research and engage with qualified professionals to ensure successful implementation of these systems in their specific projects. So, as I say, this is an intro, and we'd love everyone to pick up and use more of these systems, and of course to do that with all the support from the suppliers and from people who are familiar with the systems if necessary. Now, a quick rundown on what is Passive House. If you have managed to stumble into this webinar and this is not something you've ever heard of before in any detail, well done. Welcome on to this step on the journey. Put simply, the Passive House standard is an independent, reliable and flexible standard for achieving healthy, comfortable and incredibly energy efficient new buildings and retrofits. It's based on simple, robust software tools. It's backed up by a third-party certification process. It's been around for decades, and there's thousands of projects certified around the world. And it's all supported by a thriving network of affiliates, such as PHINZ, consultants, tradespeople, and suppliers, such as we have here today. As I say, it's a really thriving community, and we, as I said earlier, we've got a lot of events that we're holding. So, as I say, it's a great network to be part of. The heart of the process is the certification, so the third-party review, and that is sort of focused on the reliable delivery of as-built performance. So eliminating that performance gap that I mentioned earlier, where there is this sort of widespread desire that buildings perform well, and as I say, that's not happening in the majority of cases. So the certification process for Passive House is proven to be a very reliable way of delivering buildings that perform as intended, which is should really be the bar for all buildings that we're building or retrofitting. And why do it? Why choose this particular path to go down Passive House? The simplest explanation we found is that, as I say, it just works. You end up with projects that meet or exceed the client's expectation, and not unreasonable expectations of comfortable, healthy, and energy efficient buildings. I've lost count of the number of times I've had conversations with people that have moved into a new house or a new, set up in a new school, and it's such a disappointment that they have, and it's like, well, it's new. I expected it to be warm and dry and comfortable, but it's not. So what specifically are the requirements that we're going to focus on today for walls in the Passive House standard? The Passive House standard's built on this robust modelling and modelling process and certification. To actually achieve Passive House levels of performance, there are a number of requirements for the building fabric. So we'll focus on the ones that relate to wall systems. So that is, in this case, achieving airtightness, eliminating thermal bridging and just achieving a level of insulation, let's put it that way. And I've circled windows as well there because there's an interaction obviously with wall systems. But it's a topic, windows are a topic all of their own. So we won't cover them in this webinar in detail. And what are the problems with business as usual? And I want to emphasize that the following observations. We're not aiming at criticizing any specific actors within our industry. We acknowledge that we've got this current emphasis in the building code on the building code as a minimum legal standard. And that's driven by historical factors and competitive pressures. But it does sort of present an opportunity for us to sort of acknowledge the shortcomings and to raise the bar and champion best practice. So the standards themselves, PHINZ, is we're sort of responding to consultations where we get the opportunity. And I think there is really the aspiration there in the industry to try and do better. Quality becomes the norm. So in terms of those fabric requirements for meeting the Passive House standard for walls, some of them are fairly basic, but as I say, we really struggle to consistently meet these requirements with business as usual. Insulation that is uniform and it fills each cavity completely, without gaps or voids. This is not something that's that easy to do with business as usual. It's just sort of frequent surveys of, as-built projects has found. In terms of airtightness, we are trending better and better over time, but we're still kind of sitting at a level which is about, factor of 10 worse than what's required under Passive House. So there's still a fairly substantial gap there between what's being delivered at the moment for most projects and what we really should be targeting. And you can see from that last sort of section of the chart that there's still some people, in current practice that have got truly appalling airtightness. And I feel sorry for the people who purchased a new home and ended up with that. We've still got a real issue as well with vapor control in buildings. The work that Brands has done has sort of identified this issue that has been apparent to anyone, I think, who's opened up a recently built wall assembly and found that it's been raining inside the wall. So any attempt at improving the performance of walls, increasing insulation performance, has to go hand in hand with a strategy around vapor control as well, which is just not required at the moment in the building code. And then in terms of thermal bridging, I'm just focusing today less on junctions and more just on the thermal bridging that often occurs in typical wall assemblies, just because there's just so much framing in there. Our assumptions around when we calculate R values are based on quite optimistic timber fractions, when we know the reality is far worse. The percentages assumed in the calculations for H1 compliance are more often than not out by 50 to 100%, which just means that the real world performance of those walls is significantly different from what's been assumed. And what are the solutions? Well, today we're focusing on off-site manufacturing because there are different strategies for delivering sort of the significant changes that we need for wall systems. And it's not to say that someone working on site cannot make these improvements, but I think in this case we're focusing on some solutions out of the box, essentially, that you can tap into quite quickly and easily to address these issues that we've identified. Now, there's a whole range of different prefabrication typologies to consider for any project, but today we are looking in particular at panel systems rather than whole buildings. And of course, for any project, there's there's the option of all sorts of different prefabrication approaches to consider. And before we just jump into the section on interviews, to keep this productive and respectful, we're going to be focusing on the individual benefits of each system. We're not making direct comparisons between systems, and I ask that the audience questions and follow this lead. So clients and project teams are best equipped to decide which system best fits their needs, and ultimately we all want to see offsite manufacturing thrive. There's space for a whole range of different systems, and our real challenge here is changes to standard construction practices. So thanks again as well for our sponsors to jump into this space. And at this point, I'll hand over to Glenn to start the interview section. And I'd like to, I'll just hand over to Glenn. I think we'll get all our sponsors to introduce themselves and tell us all about what they're doing. But as I say, I'll hand over to Glenn to start presenting now.
Great, thanks, Guy. Appreciate it. You got that down pat. Smooth as, nice. So kia ora and welcome to the Passive House Institute New Zealand webinar series. Today we'll cover alternative wall systems with a focus on builders and tradespeople and the practicalities of how these systems work on site. We're fortunate to have three excellent guests. We have James Clark from New Zealand SIPS. We have Michael Goddard from Atamai. And we have Stefan Warner. Welcome, guys.
Glenn. Hi.
Thanks.
Hi, how are you, Matt?
Yeah, I'm good. Thanks so much for your time. Much appreciated. I think it's kind of exciting to have people who have got quite a different wealth of experience. So, and it's that cutting edge of the building industry, really, some of which you've been doing for some time. It's that early adopter, pioneering quality that we're kind of interested in. So that's why it interested me to be involved in this. I wonder, James, if you could start and introduce yourself and a little bit of why you do what you do.
Yeah, thanks, Glenn. So I'm James Clark. I'm one of the directors, general manager of NZSIP. We are a company, Cromwell, manufacturing polyurethane SIPs. My background, originally a site agent from London, then into project management, then had a construction company in Queenstown, building to Passive House certification standard. With SIPs, my SIP journey started in 2012, was when I was first exposed to it. Originally an import model. I started my pathway when I was a project manager in commercial in Queenstown. I bought a new home from a local company that pretty much fell apart on me. Had a child, he was sick, so key driver, met an industrial designer. He'd brought a SIP back from the US. We met over dinner through mutual friends, and that's how it all began, really, Glenn. Yeah, so that was about 2012 I met Michael.
Yeah. So you've been doing it for around 30 years?
Yeah. Yeah. Does it show?
I don't know what you looked like before, so possibly.
Yeah.
And so what would your why be? Why do you do this?
Why? It literally was that whole realization of poor standards, comfort levels. I was really quite taken aback. You know, obviously, there's a little bit skewed because I was a site agent on high-end builds in London, so quite hard to measure coming to New Zealand and then seeing sort of the very base standard homes that still cost a lot of money. I know Queenstown charges that bit more, but it was something that was not on my radar in terms of performance. And then obviously my son coming along, and the moisture, mold issues within a year, those kind of things. That's why I kind of said that I can't be doing with this. So that's what the driver was. Yeah, yeah. It led to my SIP journey. It led to me importing various different products that I felt would fit the model. So my pathway changed quite dramatically. Dropped my project management role and it just established a construction company.
Right.
Trying to do different types of building.
No, that's interesting to appreciate the candid kind of quality of that. I mean, mold's not a great start for any child, is it?
No, and I think a lot of us don't really realise the impact of that and how until it actually affects you directly, you could be quite blasé about it. You know, and you often get added those. You know, we've experienced it through our climate house days as well. Why would you? You don't need MVHI, you don't need triple glazing. Put another jumper on. Why do you need high R values? That comment of put another jumper on used to drive me mad. Airtight homes will suffocate at night. You know, I think everyone on here has heard those kind of comments, but still a belief today. So, you know, we try very hard to sort of break those belief systems that are deeply embedded. That's for sure.
All right, thanks very much. So Stefan, a little intro from you, please, and your why.
Yeah, cool. Hi. I started Straw Sips probably 4 or 5 years ago now, or started working on it. And before that, I had done a bunch of rammed earth building and some straw bale building, and really got into the earth building side of things after sort of experiencing sort of what they were like. And I actually studied chemical engineering, so sort of understood a whole bunch of the heat transfer and moisture transfer and that kind of thing, and really felt that earth buildings and straw buildings really handled like moisture as well as temperature really well, and just the experience of being inside them was sort of what got me into it. And then Straw Sips was really about, when you work in it, you realize that not many people can build it a traditional way, and the idea of modernizing something that's sort of a handcrafted or a traditional building method and actually bringing it up to a standard that everyone could potentially build with and anyone can design as they please, is what sort of Straw Sips is about. So you don't need sort of the specialist knowledge of straw bale building, or you don't need to design in a way that looks like a straw bale house. So you're getting all the benefits of a natural building, but you can achieve like a modern design, and everything else around it sort of integrates into relatively typical building elements around it. So that's kind of why Straw Sips started, was just trying to get as many people as it possible into having the option of building this way.
The kind of like a simplification of the product in a way.
Yes, and sort of making it uniform, standardizing it, and making it modular, so it's not, it's easy to see and understand what the panel is, rather than the idea of stuffing straw into a timber frame.
Well, great. All right. Well, no, thanks very much for that. Now, Michael, who are you, Michael? Tell us.
Hey,
what are you into?
Oh, a lot, Glenn, as you know. Yeah, so my name is Mike. I came 12 years now. 12 years ago to New Zealand, and being German, started my apprenticeship 2004, so always been in the construction industry. And how do I put this politely? The New Zealand way of building is not necessarily the way that Central Europe builds. So for us, or for me personally, it was always prefabrication implemented right from my start, from my apprenticeship. Higher R values, building airtight, building up to that passive house standard is more or less close to the German building code. So I kind of grew up with it, and it's absolutely normal to me. I wasn't aware that there are actually still houses like on the world where people live in developed countries with like single glazed windows. So that was a new one for me when I came to New Zealand. And yeah, the why is pretty much the same as James's, because like it's what we have as standard, or even some of the old housing stock is not good enough and needs to be better for the people. That's pretty much my why.
Yeah, it's not easy to find why in New Zealand, is it, with the standard of which we've suffered through all these years. Yeah. So I guess something that came up for me was internationally and in New Zealand, there's been a string of prefab and panel companies that have gone to the wall over the years. It's a tough industry to be in. You need continuity of work. The government will dangle jobs to you because you're innovative, and then pull them away. It's hard to get flow. So I guess what I'm interested in is, James, could you tell us how have you managed to grow in such a volatile section of the market, like in 2012, you say? So it's doing pretty well to provide a service like what you are.
Yeah, no, it's a good question, Glenn. It does have its ups and downs, that's for sure. I think one of the key things is who you surround yourself with. For us, that was first and foremost, and really what we were trying to achieve. I think when we set out originally, we were at that servicing passive house aspirations, which drew some attention. But I think more importantly, it was definitely having the right professionals around us that supported the product from the get-go and could share the vision. It's a massive lean towards collaboration. I think that's really key. When you're trying something innovative, it's not you, but for these markets, it's innovative. You really do rely on those professionals around you to support what you're trying to do. We are in a time, even 10 years ago, where the public are aware of what they want, what they aspire to. That helps. A lot of our end users are well versed. They know exactly what a product is, what they want. That was a big help. But yeah, for me, it was the professionals supporting it from day one. And also the likes of Scion, Doug Gaunt, Bruce Davey there in their structural team, they were incredible for us right from the get-go in terms of I spent some time up in Rotorua with them, and they were instrumental in pathways to compliance as well. But we didn't make it simple for us with how our system works, because we wanted a system. We probably if we didn't have cam locks and timber splines, Glenn, we probably could have made life a lot easier for us from that perspective. But my key message really, to anyone is, the right people around you, the right professionals that are going to support you through it, because you do have your bumps in the road, that's for sure, but it's aligning you with those that get you through it. I think one of our biggest challenges, and something that we're always pushing, is for young companies starting out as well, the costs behind certification and things like that are a real killer. That's a big problem that we continually face as well. But we're just glad to keep growing, Glenn, for sure. Keep thriving. we've got 2 big back-to-back passive houses coming up. We understand our market is quite niche, but you know, we've chosen our lane. Trying to transform the whole building industry is like trying to turn a flipping great big cruise liner. It's not, it takes forever. You know, we all sat here and we've been going at it for years, and you can see progress. But yeah, I would say we are where we are today we're grateful for the support of professionals around us and the builders. You know, we have a solid repeat customer builders that enjoy our system and come back to us.
Yeah. So, no, that's great. So, Michael, so it's that thing that keeps coming up that every conversation I seem to have around building is collaboration. Can you add anything to what James has said?
I agree 100%. Firstly, I agree 100% with him on the subject that depends on the people you surround yourself with. 2 of my really close friends here in New Zealand are structural engineers. If I have any questions, if I need anything, you know, it's those kind of things where you have to have the right people around you, designers, engineers, builders, to make this thing work. And that's the same thing with collaboration. I think there's no, in this small niche industry like passive house or high performance housing, there is no room for egos. It just needs to be together rather than against each other. Otherwise, you're not driving this forward. If it's just an against each other, then there's no, people will find it hard. People won't go there again kind of scenario. I believe the collaboration is the most important part actually of the whole design state, of the whole design process, in that perspective.
Right. So Stefan, so obviously a fairly new company. So I'd like to hear a little bit about the differences in starting something that's quite specific and bespoke, and the reception you got from council, people in general. What were the pluses and some of the challenges, I guess, in starting something that's not your everyday by a long way?
Yeah, well, it's there's definitely a lot more convincing people to do something for the first time if it hasn't been. I mean, this has been done overseas, but it's all the same with any system. People don't like it that much until they can see it in New Zealand. So that was quite tricky to get people that didn't really have any idea of straw bale or weren't interested in it at all initially. So really, we focused on trying to get people that wanted a straw bale house and let's build it off-site. And then that's kind of a different market than maybe what the passive house or high performance, you know, they've just come from a sort of different sector, but they're ending up wanting the same kind of thing in the end. They just probably didn't really even know it. And so we've done 2 projects now. We've just got a 3rd in for consent. So on all of them, we haven't really had any problems with the council, despite actually quite a lot of people going, you know, the architects or the builders that are going to do it, they've been like, how's this going to go? I'm not sure it's going to be fine. But pretty much no RFIs from any of the 3 councils related to the straw sips, which is good. And we've had people from the council out to look at them just as an interest thing, and they're fully on board in general. I'm sure there's people who aren't, but there's a lot less, I would say, like stigma or difficulty with council than people might think that there might have been in the past. There's quite a large number of like typical straw bale and sort of now more and more modern style straw bale buildings that have a huge number of different like elements to it that would be useful as a precedent for any sort of council RFI.
Yeah, and I guess one of the key things is you've got the ability to quite easily put a cavity on. Early days, I remember building my own straw bale house, and it was just a lot easier to do a hybrid and clad it with something else, and do a cavity that way with another frame, because of where things were at when the cavity system came in and where straw fit into things. So I think it's kind of a lot easier to cross that off for the council.
Yeah, and so
would you agree?
All of our projects so far have been using a wood fiber board, which is sort of always coming from Europe as a rigid air barrier, and using a vented cladding on top of that. We do have one coming up that's going to be plastered, but there's always design restrictions around plastering. And so it is much easier in terms of your sort of compliance to do another manufacturer's cladding system and sort of something that's much more common, and integrate that with our panels, which is pretty easy to do.
That's interesting, and I think something like this you could drill down into for a whole webinar, but I think we might go a little more specific towards installation process. So I wonder if, Michael, you could tell us a little bit about your installation process, and particularly in regard to on-site for the builder, if you're building frames for others. Or actually, if you're doing it, if you could just talk us through that, particularly in regard to passive house, airtightness, thermal performance, and those kind of things.
So, I mean, firstly, the most important thing for us is access to site. Our panels are probably usually a bit bigger than let's say of James or of Stefan, just because they're full walls, which restricts us in some way, and on the other hand it might make things a bit easier, but it's like if we don't get any truck access or high up access, we cannot really do the job. So that's the most important thing for us right at the start. The next thing is ideally slab as level as possible, or to make sure that it's the less leveling of our bottom plates, the better it is, because the walls are applied and they are priced, so therefore they're stiff. Then in terms of, we pretty much just lift them in with a high up, lift them into place after the whole slab or timber subfloor has been marked out. And all fixings for bottom plates are NZ 3604 fixings. So the bottom plates still get their handy brackets. They still have their concrete screw bolts. They get them at the centers, pretty much at 600 centers everywhere. We always go for extra high wind zone. We have the holes pre-drilled in the bottom plate in the workshop. So it's like fold the Intello up. We'll usually leave the bottom 600 millimeter of insulation out for easy access and to make sure that there's no moisture ingress during the construction period until the roof is on. And then if there's a hole or a handy bracket, drill a hole and put a bolt in. Kind of the same as it's like to build or to put standard stick framing up and bolt it down. The only difference is you do it with a high-up. The Intello, so the air tightness is already on in the workshop. You can see it there pretty well. So everything that's blue, that goes in afterwards on site. So the service cavity insulation goes in on site. And there is, in the corners, there's always room in behind the service cavity battens to tap wall junctions together. And depending on how complex the build gets, if there might be steel beams in there or timber beams or odd wall shapes, we might leave the service cavity off as well and fix it on site. So we pretty much amend it depending on the project.
Yeah, well, yeah, so that's useful for people to know about lifting the Intello, so you've got that ability to bolt down, which is,
yeah, you can see there. So that bottom button is not on. So the Intello is only tacked with staples. Usually, like on a 6-meter wall, it would be tacked in both corners in the middle. So you lift that up. You do your bottom plate fixings. Council engineer can come along, inspect them. It's nothing special for them. It's like standard bottom plate fixings. They came along. You put the insulation in. Take photos for either the passive house certifier or the councils. Intello down. Intello gets glued or taped to the floor. And then bottom batten goes on.
And so obviously all your ply is on and those kind of things. So you've had the inspector through, or you've taken photos. With self-certification, it might actually make your job a lot easier. And would you say that's true?
Or 100% self-certification will definitely make it easier. We've worked with the Christchurch City Council now, for example. If we have engineers inspecting it, we don't need them to come in as well. So we're just good with engineer. But yeah, it's self-certification. I think it's going to take a while in New Zealand to get that implemented as like for builders in general. We're working on quality assurance programs, but we will have to get them accepted by every council step by step. It's
right.
You can't just go and say, here's a quality assurance program. You still have to talk to the local building consent authority and get it accepted by each council. Queenstown Lake District, for example, for inspecting insulation, what we've done there is we've sent them the wall plan, which got the number on it, and then a photo of the insulation being fitted in the workshop with the wall number written on the frame and the R value of the insulation next to it, and they're quite happy with that. So it's a bit of, again, communicating with the right people at the right time before we start a project. If we haven't done it in a council, I call the normal council hotline with Queenstown Lake District. I got 2 or 3 guys there now that I know, okay, they are the right people to call. Same in Christchurch. So you just kind of work your way around and then make it happen step by step.
You get well known, Michael,
I'd
say.
Yeah, I sometimes like to be more in the background.
Infamous. And so, Stefan, your installation process, could you walk us through that? And I know with the straw bale and the airtightness, it's like ProClimate, for instance, have got a product that goes from the ceiling and down and gets plastered in. I've actually used that on one place that we did, which was an addition to my straw bale house. And it worked really, really well. I thought the system, it's sort of that overlap between European and New Zealand. This doesn't happen very often because they do a lot of plaster work, right? So if you could talk a little bit about that.
Yeah, so our panels are typically sort of up to 900 mils wide, and sort of anything below that as well. And so they're just delivered generally like higher stacked onto the foundation, and then it's relatively easy for 2 people to stand them up and move them around with a a sack barrow or something onto and sit them onto a bottom plate. And they essentially just get screwed together from the inside and the outside face. It's kind of like a double stud frame with the straw in it. So it's just a matter of stacking them up one by one and screwing them together and then screwing them down, and a lot of other hold down fixings and bracing is externally designed, and a lot of it's just relatively typical New Zealand straps and brackets and that kind of thing. So that's all kind of makes sense pretty easily with relatively typical flooring and roofing kind of construction. And then for the airtight layer, we probably would use a lot of like those Pro Climber tapes with there's ones that have, it's tape with about 100 mils of mesh into it, and that sort of can tape into the intello on the ceiling, and then the plaster can be the airtight layer. And so the main weakness of that is still maybe around like electrical boxes and stuff, but there are sort of airtight backings for electrical boxes. Alternatively, you could use an airtight, like if you're not plastering, you could just use airtight membranes, or you could have your external side of your wall potentially be the airtight layer. But if you're plastering, it is possible and just makes sense to make that the airtight layer, and use the sort of the integrations that you can with sort of the materials that are going to integrate with plaster. One of the big things is kind of like plaster often shrinks when it dries, so it will form a gap around the edges. So if you don't have that tape, then you're going to have like a 5 mil gap around all your walls that is not airtight. So it is important to be using those tapes, and it's no different from really taping one membrane to another membrane or to a ply or something like that.
Yeah, so it's an interesting point around that, the shrinkage, particularly around timber members. So it's a good point to make, and also it's interesting to me that your panels, you can move them with a sack barrow. That's definitely going to be a benefit on a difficult site, eh?
Yeah, so they're typically like maybe 130 kilos. And so we've kind of, done that to mean that you don't need a high ab to be lifting them into place. And then it is possible for people to still lift them around and will move them around without it being a problem.
So climatically, so for instance, for passive house, so there's different climate zones. Do you kind of work to the climate zones for wall thickness, or you just keep with a standard size because that modular process is the best way forward for affordability and repeatedness?
We more or less just do one thickness. So the walls are 400 mils thick, which works out to be about the width of a straw bale. So just makes it easier. And then going narrower isn't going to save you any money on the panels, and it's just going to reduce your R value. I mean, you could argue that maybe if you're on a very tight site, or a small building, but then we've done one that's 30 square meters internally, and it looks quite a bit larger on the outside, but it hasn't really been a problem. You do get obviously quite a lot thicker walls than you might expect relative to another timber frame structure.
Right. James, on the topic of installation, can you walk us through things to watch for, process, I mean, I really like that. Michael talked about the level of floor. We all know New Zealand floors are not all created equal, and so we do have to take it into account when we're using something that's square, because otherwise we're going to have a something show that rhymes with shit. So I think that's it's something that probably needs to be it just needs to be done on most projects. Would I be right?
Yeah, I did smile when Michael raised it. Yeah, 100%. And what I try and do is have a pre-start with the builders, builder to builder, having built. So just trying to identify, look out for, keep an eye on your placing of your pad is really key, that quality control, because as Michael pointed out, bottom plates, you know, they're everything ground up. You know, you get your pad right and everything follows suit. So our process is pre-start. I talk to the builder, what his expectation might be, what he's actually going to get on site in terms of the system, the builder's pack, you know, in terms of drawings. We have a 10-page install guide. I always stress to them, please read it before. I'm a builder. I know how that goes. Glenn, how many times do we park it in the site hub? But yeah, that's our real first step, is to talk to the builder. And then, you know, I'm always available for site support on the phone through the process. But I really do stress the importance of getting your bottom plate right, which stems from keeping an eye on your pad placement. It really is your first key step of quality control. And that's your first step in your inspection as well. And, you know, sometimes that does, you can get excited when you get a system turn up and there's lots of panels and Lego for grown-ups, you know, you just want to hook into it. But yeah, the pre-start, I always like to have with the builder. We do workshops once a year, and I also get to site to do training. But we hope the 10-page site guide gives you a real strong sense of you know what you're walking into when you put our product up. It is as simple, Glenn, as if the bottom plate's right, we have the panel plan that comes out with the plans, then everything just follows suit. You know, our sits, you're not having to sort of manipulate or add or do anything on site apart from stand them up, cam lock them together, footers, headers, drop them in, and, you know, just keep going around like that. But yeah, I think I'm definitely on Michael's page with the importance of that pad. So, you know, any builders on here, I can't stress that enough.
Glenn, can I just add, usually the timber subfloors are way better than the concrete subfloors. I was just going to add that one.
100%, yeah.
Or offend anybody.
Yeah, we do timber subfloors. Thanks for that, Michael. Yeah, they're actually proving quite popular. We're seeing more and more of our sit floors now on the market. 5 years ago, we definitely weren't, but they're growing popular. But, you know, I think one of the good signs is you've also got companies now specializing in just doing slabs, and that does help. But you do still have to keep an eye on it. But I can't stress enough though for builders, keep an eye on the slab, read the 10-page install manual. It's a very simple, you know, step guide to putting our panels up, and then have the pre-start meeting, and just remember we're a phone call away.
Yeah. And so what, as far as like you get a run of panels on a long wall, what will you tend to drop off in order to not poke out, so to speak, keeping it in layman's terms?
Always do your running measurements. The first one I ever did, Glenn, and I was very excited, and I started putting, it was a 16-meter run of wall, right? And this is how we got to know what we needed to put on our install manual. It was me and Michael Sly at Jack's Point, and we just unloaded the container. And we put all these panels up, and we were shunting them, and we were pushing them, and we got to the end, and we had like a 30 mil overhang. Thought, oh, God. Of course, in our excitement and a little bit of stupidity, we hadn't sort of held them in place as we went. You know, just keep pushing, and and you hook into it. So, but I think that getting that bottom plate right, and it's true, it's square. The sips will follow that plate. And the cam locks will put everything together tight. Check your openings as you go. But running measurements are key. I always sort of say to the builder, do 5 or 6 panels, check where you're at. And then carry on.
You've segued beautifully there, James, into the cam lock. Because I remember years ago when I think you were bringing them from Canada or something. Would I be correct? Like early days?
Not well. Originally, I originally imported from the US.
Right.
From North Carolina.
And they had a cam lock system then, right?
Yeah, there's quite a few globally. There's some really big companies in the US, and because at the get-go we were kind of striving for that passive house, we were trying to strip out as much timber as we could, and just have whole walls of polyurethane. The cam locks gave us that ability, and because we actually foam inject in the factory, they're embedded within the panel, so they're molded in. A lot of people were very skeptical about them structurally, and the kind of, as you would be, why wouldn't you? I was the same when you do your due diligence, but we were really drawn to cam locks for thermal efficiency, but also speed on site. We were finding that panels together, cam lock them in, pulls it in tight. That helps with achieving that air tightness as well. That once we'd started the cam locks, we could never go back. It just made perfect sense to us. And the key thing is it's fun, Glenn. Puts a smile on your face. You turn that key. Yeah, it's quite a good feeling.
And it makes for a reduction in timber too. Did you just say that before?
Yeah, it does. And again, driven by, we were trying to get the maximum performance out of the panel, and also that labor, and because I had a construction company at the time, and we were always looking to speed things up, and how best to do that. And the cam locks do it beautifully. It does reduce that timber content within the panel.
Great. Now I've got a little chat here from Guy in the chat, and he's DM'd me, so he's probably hoping that I wouldn't say his name, but that's been done now. But he's got a question for Stefan, and actually what I would do is encourage people to start putting their questions in the chat, because it is quite good to know how much time we need to allow at the end for your to answer the questions, so you don't go away dissatisfied. So a cheeky question for Stefan. This is Guy's words. Apologise from herewith. How receptive have you found the earth building community towards non-traditional approaches of airtightness and prefabrication?
So I'm just laughing at Guy to sending it to everyone now.
The earth building community, it's probably split pretty half and half down the passive house, airtightness, mechanical ventilation is a waste of time and is going to poison your body. And then the other half is on, into passive house and understands it. Some people want to build everything with their hands and have it entirely made with earth materials or something like that. And they still work well, but it's not the reality of most of the way people live. And a lot of climates, like Here in Wanaka, to be honest, in winter the air quality is pretty low with people burning, having their wood burners going. So having a filter in your mechanical ventilation means you don't have to open your windows in winter and you're breathing fresh air. So something like that is a massive advantage versus if you don't go into, if you go traditional, you're gonna have to open your windows, and potentially less healthy than having a mechanical ventilation. So I don't really get into it. I just let people do what they want. And most people in the end up designing with something that's closer to a passive house system than a non-passive house, traditional earth building style. I think I was pretty finished. I would say that the prefabrication has been mostly pretty receptive of most. Some people still want to build the traditional way, but I think they'll only ever do that once, and then they'll go, I never want to do that again. And just the time saving, the amount of effort that you have to spend, and the fact that you're going to spend weeks doing your walls versus probably 2 or 3 days is just a massive difference for any type of building to actually see some progress.
Yeah, okay. Question, and so it's it might be putting you on the spot a little bit, but is there any, I'll start with you, Michael, because I know you the most, so I can put you on the spot the most. Is there any detail that you would like to drag up and talk about for a couple of minutes, so that to satisfy the nerds amongst us? So is there anything there that you would like to talk about that sort of sums up your panel and the parts you like about it, or even your project that you did?
Yeah, there's well, that photo is actually not a certified passive house. That's my own house.
Yeah, that's your.
Yeah. Yeah, you know that one, don't you? You've been there.
Yeah, I do. I've been there. Yeah. I didn't there at that stage. I was there at the stage that you could walk on things, like the mid floor.
Yeah. I mean, the thing with the atomized system is it is nothing that's like reinventing the wheel. Like the framing is, unless it's an SED framing, the framing is still the 3604 framing. There's a couple of connections, which is screws from the exterior or screws down the bottom plate. You can see right here the Intello being folded up, the same what I just described before. On my place, we had on, what was it, maybe 60% of the walls, the cladding on as well. And the windows were in. That's Tortora Street. That's the certified passive house. On Tortora Street, in terms of there's nothing really in terms of like connections where I can say, oh, you really need to watch out here, or you need to watch out there. The main thing is you need to make sure that you get the continuous airtightness right. So you probably need to have a sit down at the beginning, if it's like one of the first times where you're doing an airtight build, where you're like, okay, how are we connecting what together where? So you're not missing a potential connection strip or things like that. But other than that, it's more or less just like putting standard frames up, to be honest. Is that the answer you want? Or is that even answering the question you were asking?
Oh, I mean, I guess that's pretty important, because it tells you what you value around the system.
Yeah, it's really tried to keep it as simple as possible and not reinventing the wheel kind of thing. Just work within what New Zealand got and try and optimize it towards the point where it can be passive house. And realistically, I mean, if you look at like Auckland, you probably get away with a 4x2 frame, an R2.8 and a surface cavity to achieve the insulation values required up there. So, it's not, you don't need to change a lot to actually get there if you want to get there, if that makes sense.
No, it does, and it's a good point actually between climates. We need to pay attention to the climate we're in. I'm in Nelson, and I often get frustrated by the fact that people go, "It's not cold here." I go, "It gets down to 0. I don't want 0 inside my house, so it gets cold here. So we need to attend to that. Nobody wants that in their house." So, no, that's a great point. And so I guess, James, for you, what would be one of the key takeaways for people, or a point or a detail that you would like people to go away with?
If you've got a ridge beam coming into a pocket, just remember your straps that go on the outside face of the panel onto the top of the ridge beam. Do not forget those straps. So I think my key takeaway again is it's just site documentation. Read those little quirky engineers details that do pop up, and that for me, it again echoing what Mike was saying. A lot of it's a process, and you're standing things and you're putting things together, but it's just check all the details. We've got QR codes on our drawings that lead you to standard details, but it's always those little straps, but use the QR codes. But yeah, I often find I'd often get the odd call, "Oh, was there meant to be a strap that went up the outside face and on top of the ridge beam?" And you're like, "Yes, there is," especially in extra high wind zone uplift, So
I hope I'm not getting that after code of compliance.
yeah. Yeah, so that I just can't stress enough it's something. Just follow your documentation. There's nothing in terms of anything too wild that you really need to think about, but just check your hardware, and those little details are important. Yeah,
that's great. And Stefan, on that particular topic, or
well, our framing essentially is not 3604, and a lot of that is due to the stud spacing. We often go 900. So you can't really use that, like plywood bracing on the outside. A lot of people have wanted to do something like that, and it's firstly it's outside of their sort of manufacturer, the providers sort of bracing tests and specifications, the fixing that would have to be done. And also we are mostly using sort of a wood fiber board, which is vapor permeable, much like sort of equivalent to the straw on the outside, which is not a bracing element as such, but it is a rigidity barrier, and just keeping the vapor permeability of the whole wall system is very important with the straw. So most sort of eco-ply or rigid wrap type systems wouldn't work for a number of reasons. So that's one thing that needs to be considered. I would actually say that the wood fiber board, which we're typically using like Styco or IBS Eurowall, they're actually easier to install than a plywood or OSB or something like that. They're all four-sided tongue and grooved, and they just you can basically wrap the whole building in a day or two, and that helps to protect the building as well. So that's the main difference with our framing system and how the external side of it is done to a lot of building these days.
And so the introduction of the Styco, you're basically, or the wood fiber, is that for a little bit more insulation, continuous insulation, or is it, yes, talk me through the why of that.
It's I mean, that does help if you use something. It can, the Styco's 35 or 40 mils and
40
does
mil.
do a thermal break, but mostly we're using it for the weather protection, and sort of a barrier and to protect the straw, but also now you've got a nice flat surface to install your battens onto. And so in a lot of places, it's actually like wall and roof, and it provides that sort of rigid air barrier without having to use sort of a non vapor permeable, or much less vapor permeable product, which potentially you could be like condensing moisture on the inside. So that's not going to happen with the wood fiber. And so what actually happens is the battens, the wood fiber is kind of just tacked in place, and then you're using sort of 45 mil structural battens, and that's fixed all the way through back into the studs of the panel.
Yeah.
So the wood fiber is really just sandwiched in place.
So assumedly you can join anywhere on the wood fiber because it's not a structural member.
Yeah, so you just run flying joins with the tongue and groove. It doesn't need to hit a stud.
Yeah. Okay. Oh, that's interesting. Because wood fiber, I just feel like in New Zealand we have so much wood waste. It'd be great if we were using it a little more, but it's starting those big factories. Huge amount of money.
Stefan, quick question: is the Steiker? Do you still have to put a building wrap over it now, or is it by now as well rigid air barrier approved?
We've done both. We've done without a membrane building paper on, and then with, depending on maybe who's designed it or who's building it and what they're comfortable with. But
got you, cool.
In our opinion, and very a lot of climates, it's not necessary.
The reason why I'm asking is because I looked years ago at it, and obviously in Europe we don't put a membrane over it.
In Europe, you'll plaster it, wouldn't you? You'd bang plaster straight on there.
Yeah, wall would just plaster straight on. Which,
quite different to here.
Yeah, definitely a different approach.
Oh, that's great. I suppose I think I'd quite like to finish with what does finish before we have some questions. Hopefully, I haven't looked in the chat recently. We're not over endowed with questions here, but there are some. So I would like to ask you guys, each of you, what the future looks like in your lane, like basically in the prefab, and in particular with you guys' product. If we could start with you, James.
For us, it's a bigger press for bigger panels, and we were 2 minutes shy of our 60-minute firewall rating, so we are after that 2 minutes.
Yeah,
that's us this year. So we've always aspired to create bigger panels, and the market is definitely asking for it. But yeah, we'd love to complete our suite of documents with that 60-minute firewall for sure. And then we've got new tech manual coming out as well, just as a reflection of probably our last 4 years of growth, Glenn. And, as the system evolves, as it were. So yeah, that's the future for us, 25.
And the future of prefab and the uptake, those kind of things, like for SIPs, for instance, where do you see it in, say,
Yeah, it's strong. Like we have a smart series that we do in conjunction with energy architecture, and the inquiry around that is phenomenal. And we're moving more and more of our sort of smart series buildings. So through that mechanism, that's what's driven us to sort of put together the floors in different kind of sections. We always have to consider transport, and also, you know, to a degree, stitchy knitting in terms of we make panels and put them in packs, and then we send them. But yeah, I think anyone that is now seriously looking into prefab ventures, I strongly support it, the prefab industry. There's someone on this chat that many years ago said to me, well, you wouldn't order a brand new car in a box and assemble it on a driveway in the pouring rain. Yet that's how we build houses. And it's stuck. It's stuck with me. One Mr. Guy Shaw, and I've never forgotten it. And so, you know, as much as we can assemble under a dry roof is the way to go. As many of that parts as we can do, and take out a lot of the steps on site. And you've got all sorts of things, health and safety, and you know, there's a lot of costs with time on site associated with it. So prefab, it's a tricky space, but one that needs to grow. I think it's an important space. We should be getting into the mindset of manufacturing homes off site. Sweden is a great example of how it's done. You know, they've got it down pat.
That's great. Stefan?
Well, the future for us is really just focusing on getting the projects that we've got lined up out the door, but also trying to get a bunch of the systems around how things like the roofing works on site. We've sort of been, and then even looking at the potential for doing some sort of roof panel that is a straw sort of panel, but yeah, that's been a bit of a challenge. And so typically we've just been doing some other roof system, but it's probably, I guess, like James said, you don't really want it pouring with rain. So having the ability to go walls and roof is something that we really want to be able to do.
Yeah. And I guess a quick question on the side would be, you know, EcoCocon, they overseas, they've been doing it for a wee while now, and they've seen quite large growth and quite innovative. And did you ever see them as kind of a influence, or?
Yes, yeah, definitely. I mean, I'd say relative to them, our equipment is very low tech. So there's always, like, you know, every time we pretty much do a project, there's something we will change or rebuild with the equipment to make it easier and more precise or more efficient. And so it's kind of a gradual improvement at the moment, rather than building a whole new set of machinery that may or may not work. And so just sort of meeting that demand, really.
Yeah. And young Michael, what about you? What are your friends?
Well, we're up to for 2025. Probably a bit more R&D kind of stuff. I'm pretty happy where we're sitting in terms of workshop and the productivity there. There's not that much we can currently improve there, but if we get a bit more into the CAD space and then get the detailing better and even more accurate, so that we can really take it to the next level, and like, yes, every steel bolt, every this, every that is pre-drilled. We know exactly it fits, rather than being like, okay, now let's drill that hole on site just to be sure that it works. Because that then opens also the market to supply to more builders that we necessarily haven't worked with yet. And also I would like to get a bit more into the multi-residential part, which will require a bit more R&D on sound and on fire, which I'm slowly working away on in the background. Those are pretty much the two main things that I wanna push for 2025 in terms of R&D. In terms of efficiencies in the workshop, we would probably have to go automized there to make it any more efficient. But then on the other hand, I had chat with several guys back home, and they were like, "Look, you're quicker with a drop saw than you are with a K2 or Fundecker." So it's like weighing up the cost benefits, and we're sitting pretty good there at the moment. And generally, in terms of the prefab market, I agree with James there that it's taking up more. It's getting taken up more and more. More architects, more designers, government developers are interested in it. So I agree there as well that it's probably right now a good place to be in, and slowly develop the company more and more.
Right. No, it's good. Like I think you're doing something that's got huge potential, and all of what you're doing has huge potential. If we can start supporting those kind of things, then the uptake drives affordability, and it's all about supply. So yeah, great to hear those answers. Zoe McCluskey, price-wise, could all three prefabricators provide an idea of the cost comparison with traditional construction for homeowners? What about feasibility price-wise for developers to integrate your different solutions into the medium density developments? Starting with you, James.
Yeah, question you get asked every day. And against timber frame, 90 mil standard timber frame, we're 15% for sure. More. It's a performance criteria question. But yeah, I think, Glenn, you just said something about the more uptake, the more we can manufacture, the more you push through, and the more the price of things come down. Couldn't be a truer word. You know, it's all about throughput. But yeah, in terms of our system, if you're looking against a standard 90 mil frame system, we're always going to be more expensive. We calculate we're about 15% more overall. But as we all know, sat here, the performance, the comfort levels of that home is probably 100 times more. So most of those sort of things, what I say to people is you've just got to weigh up how you want your home functioning, what your goals are in terms of performance. But we're just not in a position to be competing against standard stick frame for sure.
Yeah, we built for people, and they made compromises. They didn't have a garage, or there was no deck. There was, a pallet to get into the house when we left. Not that we'd clean them out financially, thanks very much to everybody, but more to do prioritize that were important, which was fabric first, So
fabric first.
You can change your kitchen, but it's very, very hard to change your walls, team, isn't it?
It's
Stefan, what do you think?
Sorry.
Yeah.
No. I would probably say we would be similar to James. We would be more expensive, but if you went on an equivalent sort of performance of wall, maybe it'd be a lot closer. There's also the fact that really walls in a whole house, you might be spending $500,000 or $1 million building a house, but your actual wall structure cost is not very high of percentage of that money. So it is potentially slightly more expensive, but those cost savings and energy consumption will probably pay themselves off within a year or, a couple of years easily. I haven't found so far that it's anything's been like a deal breaker on the cost. You know, we've sometimes looked at it and gone, oh, we're maybe $3,000 more than your frames would be, but you might have unknowns in the install cost that in the end it might work out similar, but it's almost been sort of pennies rather than big dollars on the price difference for the overall build cost.
Yeah, and I think that's a really good point that you make around what is the actual element worth in comparison to the cost of the entire system. So, you know, I think quite often we just freak out and go, we can't afford it, we can't do it, before we actually work it out and prioritize. So
if you can't afford a high performance house, and you can't afford the normal 3604 house either. Like if you can't afford a hill build or a high performance hill build, then you can't afford a standard 3604 hill build either. You're talking low money to bring it up to the standard of the high performance part, at least thermally modeled, compared to having just a standard build there. That's my opinion on it.
well, I guess the elements that you're adding are surface cavity, air tightness, ventilation system, right?
Yeah.
So then you've got a trade-off. Have you not
Yep.
on the ventilation system, heating system? So you can use a smaller heat pump.
Glenn, what I'm trying to say.
It's kind of like putting it in take.
Yeah. Now what I'm trying to say is, if you're already with your budget from the start, that hard against the wall before you start building the house, that you can't afford those high performance elements, then you shouldn't be building that house right at the beginning. That's my point of it, and you should reconsider whether you want to do it at all. And I mean, cost wise, I would say same as the other two. Our QSs have done the calculation several times, actually being like, okay, we've built this house now with Atomai for that price, and that's what our true internal cost was. How much would we've done it if we take the high performing parts out of it, the better insulation, the air tightness, the surface cavity, and it's always come in around that 10 to 15% mark. It seems to be the magic number. And in terms of developers, because there's also that question about developers to integrate the solutions. There's, for example, a developer here in Christchurch, Nest. They do that. They do build to a better standard. They had several of their projects now done or modeled to low energy certification. The Tordera Street project that we had was actually for one of the directors of Nest. I think a lot of it comes down to what does the developer want to achieve? Does he actually want to build better and might have a smaller margin? Or is it all about the cost needs to be as low as possible and the margin as high as possible, kind of thing?
Yeah. Points, really good points. And I think the cost, as you say, you can do 3604 and burn plenty of money based on design, right? On the hill or whatever. So they're all, horses for courses. So now we've got one more question here, and then we'll close out. It's from Anne McKenzie. Great presentation. What is the lead time for ordering panels? Starting with Stefan.
We would probably be around 4 weeks from when the builders are actually going to be ready for it, is when we would probably start. So the lead time of it needs to be organized way before that, but the actual point in when we need to know sort of foundation and how long they're going to be needing for that, and then we would only really need 3 to 4 weeks for a typical sort of I don't know, 80 to 150 square meter house.
Okay. And Michael?
Kind of the same as Stefan. Usually we're involved way earlier, like with concept designs and going all the way through. But when it comes to the point where the builder's like, okay, we're going to start on site with the foundation, when can you be here? Or when can you deliver the panels to us? Depending on the size of the house as well, I would say like up to 100 square meters, probably around the 2-week mark, where we really need to be like, okay, we're going to have to start now to make it to site in that time. And like for a project bigger, like 250 plus square meters, I would say we need around the 4-week mark. But that usually involves as well getting trusses sorted, get pre-cutting rafters, those kind of things.
Right. And James?
Currently 6 to 7 weeks. Yeah. Just depends on the workflow and the Gantt, but we generally average 6 to 7 weeks.
Right.
Smaller projects, we try and accelerate it if it's possible.
Okay. And if you think about the process of building, you know, that's not gonna, you're not gonna be waiting for them in that process time unless you're disorganized. And so what we've got here is one more question. Are straw SIPs similar price range as SIPs EPS panels? You may or may not be able to answer this one, or but it's kind of hard to know unless you guys know each other's working. So I'm not sure what you think about answering that one.
I'm not sure. I'd say most of our projects end up $250 to $280 per square meter of wall. So, it sort of depends a little bit on the project, but typically around that.
Yeah, they're quite different systems, so it's probably
it's a little bit different because
worthwhile.
we have some other elements that need to be added, and that's maybe another $20 or $30 but they might not need to be added. So it depends on the design a little bit as well.
So, yeah, no, that's good. All right. Well, I'd like to thank everybody for attending today. It's been really interesting for me to talk to you guys, and I've learned a lot. And we could go on, being building nerds that we are, speaking for everybody quite broad. Appreciate your time. And wish you well in all your businesses, and thanks for supporting PHINZ. Yeah, thank you very much.
Most
Thanks,
welcome.
Thank you.
Thanks, guys.
Cheers,
Yeah.
Michael. Thanks, Stefan.
Thanks.
Bye.
Bye.